Failures. I love failures. I hate them because what it does to our business, but I love what we learn from them. This is a failure I was at in Missouri. These are big blocks, I think 3,000 to 4,000 pounds a piece. This is a really tall wall. There's a negative slope above this wall. There's no drainage gravel to release hydropressure in that wall. There is no geogrid. There's no tiebacks. There's nothing right, not one thing right about this project. Not one thing. And I have no idea who would ever think that they could keep this thing and this should be built. This height of the wall, these blocks were 3 times that distance away from the wall. That's how it blew when the water pressure built up in there. It just blew those units away like they were toys. It's amazing. Got a couple of other failures that I worked with. One was a backyard. They had lost everything in their backyard. They had 3 feet left of their backyard. It was a 10-foot vertical drop and then slid down 90 feet down to a creek bed down below. And I couldn't get back into that backyard. There's no access. So I blew out the back of the garage, took the cab off my excavator, took a winch truck and tied it to a tree across the street and dropped the excavator vertical for the first 10 feet. And then I crawled the excavator down below. And then I built chutes out of the back of the garage. And we shot all our gravel, all our grid, all our blocks, everything was shot down this chute. And we'd shorten the chute as we built it up. And I rebuilt that whole bank, terracing it all the way up and kept creeping up higher and higher and higher. And that was a situation where they cut all of the tree growth, the shrubs. They wanted to clear it, so they cleared it as homeowners. And you know what roots do? Roots are like a stabilizer. They're like a reinforcement to soil. It's a natural way of keeping things from not sliding and just destabilizing. And they cut it all down and it failed. Everything on either side was treed, stayed exactly where it should be. That homeowner had to spend that $100,000 to rebuild that little area because they did something wrong. But they had no choice, otherwise the house was condemned. Another project, I was in Seattle, and if anybody's been in the northwest, it rains and rains and rains, and will rain for days and days on end. And I was working on this, I went to see this project. It was Dale Ellis. He was a shooting guard for the Sonics at that time, Seattle Sonics. And his backyard, the plumber had the excavator, and he says, oh yeah, I can install walls. I got an excavator. So he installed these walls, and there wasn't a wall that was taller than 6 feet tall. In fact, the lower wall was just 6 feet tall, and there's a full-on basketball court, full-size basketball court, and then the lake. And then the terraces above that, and it was all about 22, 24, I think 20 feet tall, all of this area. All landscaped, irrigation, lighting, staircases, planting, everything was in place. And it blew out. And the bottom one units were 24-inch Keystone standards. Anybody worked with 24-inch standards? They're big, hollow, they're big solid systems. I mean, big units with the pin. It sheared, the pressure sheared all of those pins off, and the blocks were across the court. And remember, this is not more than 6 feet tall. I went back in there to repair it all. We had to take everything out. I had to create these little pathways going all the way down, little excavators, little bobcats. Everything had to be drawn out of there. The contractor lost, the plumber lost his business, plus a lawsuit. And when we were rebuilding that, it was the the county, the engineers, everybody was crawling around, making sure that we were doing it correctly. Well, those are failures that really should not have happened. And the most tragic failure was one that I didn't get involved in, luckily. It was my brother's friend in the interior was building their dream house, and they were going to use mafia blocks. Do you know what mafia blocks are? These big things? I think, what's his name? Hoffa is in one of them. But they built this 20-foot high wall with the excavator with no tiebacks. The wife was on the survey stick, and the husband was looking at it. And they were just finishing off with the excavator, and the wall blew out and killed her. It fell on her and killed her. They had 5 kids. And we told that guy, don't do it without engineering and proper design. Don't build this wall. We're not interested unless you do that properly. And he didn't. He thought he knew better, and he killed his wife. So we guys really need to be aware. As contractors, do understand how structures work, what a good structure is, and stop and don't build something unless if it's done properly, it's designed properly. It's really critical, because on pavers is a dip. I can repair that. It's not going to kill anybody. It's not going to hurt anything. It's not going to change anything. But a wall, when you start going vertical, we really need to be aware of what we do. So really be conscious of what happens when something is improperly built and improperly designed. Face connection. Remember, I talk about a system. How well does a system work in every kind of situation? And remember, the DOT requires a positive connection on grid to block. Well, this particular product has no connection, none at all, to the grid. We have all grid is all still in good shape. This is a huge wall. This is over 40 feet tall. It's in Arizona. I went to see the project. It was a Lowe's. They had just built a Lowe's building, and they had just put the blacktop in, and they hadn't taken the filter fabrics out of the drains. They had 3 inches of rain in 3 hours. The whole back parking lot flooded and came to the wall and blew out the face of this product. There's no drainage rock in there, but still the structure, the retained soil or the reinforced soil zone is still in great shape. They had to buy all the properties in front of this wall, and then 40 feet in front of this wall, they built another wall and buried that wall. Somebody lost a lot of millions, right? And it's just something that we have to be aware of. Remember, water, number one, that's what hurt this. But if water is going to come behind our wall, we need to make sure we have a right system that can accommodate that water. Here's another failure. It's a different failure. It's global stability. You can see the bulging in the front of the wall. This thing's still standing. That whole thing rotated and rolled out of there. And that's because there was a negative slope below the wall, but all of the water from all the downspouts, all the backyards, all the driveways, all the patios, everything, where did it lead? Water to the back of the wall. Flooded this area, saturated it, liquefied it, and rotated the wall. So when you do something like this, we need to have deeper burial. We need to have deeper, longer grids. There's a plane. It's called a global stability failure plane. It looks like this. And we have to cross that failure plane. Global stability is something that we have to consider when we get into taller walls and walls that have a lot of loads on them. This has a different stability or instability. They don't have that fourth wheel. But they've been on this, good teamwork. She's been on that fender before. They're really a cute couple. I think that, they've got this all figured out. So there you go.